see that, please ask me and say, like, hey, are you recording? Because I forgot last week a couple times, which is fine because then I can record in the afternoon. But I always start with this screen so that if you're sick, like Aubrey, who left us, Aubrey, feel better, please. Or stay home. Either feel better or stay home. One of the above. But yeah, so then if you're sick by the afternoon, my goal is by extensions, my videos are up on my YouTube channel. Okay, it is illness season. If you're sick, stay home. So in your table of contents, we should have 5.2.2 for probability simulations marked on the right page for where we're going to take notes today. And then let's go to that page in our math journal, starting a fresh page. I would get a sheet of graph paper. Anybody, if you forgot your math journal at home, I'd get a piece of graph paper so you can then just tape it or glue it into your math journal. I would not use your toolkit. I know we did a lot taking notes in toolkit in the first semester, but I would rather you just use your math journal, so I would advise don't use your toolkit. We're going to use that as a reference this quarter. So we're going to skip through this. You guys are always more than welcome to read this stuff, especially during that first 5 minutes. But what we're going to do today is simulations. And again, if you're in the digital text, if you click on it, simulations will pop up with the definition for it. A simulation is when we try something, when we do it, right? So if you do like a science experiment, you're going to be doing simulations. We're going to be doing simulations using those TI-83. Oh, I missed you guys. You need one still? You get mine. So hang on, we're not using those yet. Let's talk about random numbers. What does it mean when something's random? So it's not calculated, like it's unexpected. We can't, well, I was going to say we can't predict.
Like randomness, but you don't know what it is.
Ooh, so wait, you said sometimes we can what randomness?
We sometimes expect randomness, but we don't exactly know what it is.
We can expect, I'm going to change one of your words, anticipate might be a better word there. So we might be able to anticipate what randomness is going to happen. So if we have, let's say 20 numbers, right? The numbers 1 through 20. And you're going to randomly select them, right? We could put them in a hat, shake them up, mix them around, give each of them like a marble, put them in a bag, or you can use technology to do this for you. And we're going to talk about that in a moment. But let's say we've got these 3 different games. Now we're going to have to define a couple of these things, make sure that we know what's going on. What's a prime number? Number. Yeah, only factors. So the only thing it can divide by, only factors are 1 and itself. So if you can't immediately think of that, what a prime number is, please write that down. A prime number, prime means only factors are 1 and itself. So 7 is prime because the only way to make it with integers, right, with whole numbers, is 7 and 1. But 9 is not prime because we can make that with 9 and 1. Or what else makes 9? Multiplication. Just yeah,
3 times 3.
3 and 3. Grant?
I'm drawing a blank on what the page is called, but can we put that on like the formula page that we have?
You can't. So a lot of vocab we're probably going to keep in the lesson. So I would write prime, maybe in all caps or underline it or something. You could, but we're going to put mainly like math formulas on that page. So I would not necessarily put vocab on that page. I would put this on this lesson page if I was advising. I mean, of course, it's your math journal, so you make your own choices. And then we should know what even is, right? Divisible by 2. And then sometimes we take another step that's not odd, but we talk about divisible by 3, like 3, 6, 9. But this says a number not divisible by 3. So not 3, not 6, not 9, not 12, not, okay, you get the picture. So let's talk about the theory. Ooh, another word we don't know. So I'm going to flip over my notes page because we're going to write down a couple more vocab words. And this is also why I advise just stay on this page because we're just going to get a few important vocab. So I got 2 more words for you. Theoretical, and this is in your book. I need to go ahead and throw the book on at the top to make sure that I'm spelling this right, because quite genuinely, spelling is not my strong suit. Theoretical. Theoretical. Please write this down because this is going to be on your math test, not defining it, but you're going to have to work with it, so you got to know what it means. Theoretical means what we expect to happen. Based on math. Or data, really, like it's information that we know. And the other one's actually easier. If it's not theoretical, then it's experimental. And these both deal with probability. What do you think experimental means? If theoretical is what we think will happen, Alex?
What we know will happen by testing it.
What did happen when we tested it? But yeah, I agree. What happened? If I could spell right. So I would, in your notes, underline these, put these in a box, highlight the main word. By the way, again, a reminder, these are for you, not to keep, but to use. So if you have highlighters, there's tons of them all over the place. So theoretical is what we think will happen. Experimental is what we got when we did it. So A says, what's the theoretical probability player X wins that player Y wins? And so how many people are playing this game? We have player X and player Y. Okay, that's it. So do we have these? Can I scroll? So if we look, and I'm going to help you with one of these and then have you guys do it on your own. Crap. My smartboard is slightly off today. So for part A, so we're in question 34, part A. And I like blue better than I like red. Red's a little abrasive. So in game 1, I'm going to label this like G1. Player X will win if he gets a prime number. So we're going to say P, the probability of getting a prime. Right, the probability of getting a prime. How, again, do we figure out that fraction for our probability? Don't give me numbers right now, but just give me words. Like what over what?
Part over whole.
Part over whole. And what do we mean by part?
Like how many numbers are prime, and then whole how many numbers there are.
Prime over our total. So we have to figure out what numbers are prime. So you don't have to do this on your paper, but I'm going to go ahead and list these out, and we're going to look at them and figure out how many are prime. Let's do purple for prime. So let's just do yes or no. 1. Is it prime?
No.
Ooh, see, there's this big argument on whether 1 is prime or not. We're going to leave that for now. 2?
Yes.
Yeah? Only 1 in itself. 3?
Yes.
4?
No.
5?
No. Yes. Sorry.
Yeah, 5 is prime. 6?
No.
7?
No.
Only 7 and 1, right? There's no other 2 numbers that can multiply to make 7. 8?
No.
9?
No.
10?
No.
11?
Yes.
12?
No.
13?
Yes.
14?
No.
15?
No.
16?
No.
17?
Yeah.
Yeah, 17 is a weird one. Think about what numbers could multiply to make it. Yeah, it's odd. When it's odd, think twice. When it's even, you know it's a no. So 18, of course not. It's even. 19? Yeah, it's prime. So how many is that? 8 numbers, right? So 1 is not prime in the sense of what we're talking about here. There's a big mathematical argument, a long time argument that depending on what mathematician you ask and how they define it, you could make the argument that 1, well, the only factors are 1 and itself. But because itself is 1, it gets really messy. So our probability comes 8 over what? 20, right? Because there's 20 total. I need you and your partner to kind of do this process for game 2 and game 3. But before you do that, if this is the probability that player X wins, then what about the complementary situation, the probability of it being not prime? If we know the probability of being prime is 8 out of 20, what's the probability of not being prime? How do you know that?
Just do 8 minus 20.
Yeah, it's everything that's left. If 8 of them are prime, 12 of them are not prime. So that answers both parts of A for game 1. Try game 2 and try game 3 with your partner. I'll bring it down on this screen so you can see it more easily. You should have a book out. So we got even number and not divisible by 3. There should be a lot more talking happening right now. You are not looking at the board. You are doing stuff on your own. I'm just doing this when we come back together. I'm going to use cards. I'm going to give you another minute or two. But if you're sitting there and you're like, man, I hope he doesn't draw my card, stick up a hand and ask me a question. So take another minute or two, but I'm going to use cards to call on who's going to help me next.
Oh, you think more. Are not divisible by 3. There's what, 3, 6, 9, 12.
Yep. Put it in a fraction. See if you get a decimal Or a whole number? You get a whole number? It is 3 over 3 is 1. That's the easiest one. I mean, you can do the division, but if you think about the fraction, it's the same thing. If we have a contiguous set of numbers, meaning they go 1 to the next, there's no gaps. 1 to 20. We start on an odd, we end on an even. Then Zoe, how many of those numbers will be even? Half of them, right? So here, 10 of them. What if we went to 30 instead of 1 to 20? We went 1 to 30. Yeah, so we could always do half of them, right? So if we go 1 to 50, we can do the same thing. So you don't even have to think on the even part. You just know because we start odd, then go to even, half of them, right? So 10 out of 20. So then when we look at the complement situation, the not, I'm just going to put a big E for even. How many of them are not even? Alan? 10 out of 20. Still 20. Our total is still 20. So divisible by 3. Ella, what do you think here? How many? So it actually asks you a number not divisible by 3. Do you know why I did divisible by 3 before I thought about the not? Yeah, because it's easier, right? I always want to take the easier option. So we first think how many are divisible by 3. How many do we get? 6 out of 20. So then how many are not divisible by 3? 14, right? Just how many are left over? So 14 out of 20. Does this make sense to us? We just go through and we say what numbers like have these characteristics, how many over the total. So, but we didn't actually try any of that, right? That's what we expect. Turn on your calculator. Clear anything that's there. And then go to the math menu. Do the first 3 steps, then don't move on, please. First 3 steps. I don't have one, so you're just going to have to follow the steps. Can't watch, got to follow the steps. Partners, please check on each other, make sure we're doing this right. Oh, hey, at the end of class, somebody should remind me to hand back papers. If I don't get to it, I'll do it tomorrow. Is everybody in the math menu? So there's a button that says math on your, like, literally left-hand side of the calculator. It just says math. Yep. Yeah, up at the top it says like math, num, complex. It's like when you guys text each other, right? Yeah. It takes out the vowels. Are we in the math? Good. All right, now click to the right over to the probability menu. It says either PRB or PROB, depending on your calculator. It'll either say PRB or PROB. Then go down. It says random. That means random integer. Click that. Like hit enter on it. Hit enter. So you're essentially hitting enter when the black box is over the 5. So you're going down with the directional pad. So go over the directional pad. To the right over the top. Going over. Now it should be asking you questions. It should be asking you questions. Now, depending on your calculator, depends on what it's going to look like. Give me your eyes for a second. Black calculators are a bit older. It's going to make you think through the process that you're giving it. So, it's going to actually be a bit more complicated on the black calculator, so please listen to me. There's a comma right above the 7. Okay, first off, find the comma. What we're going to type in on the black calculators is the lower number that we have, the 1, comma, the upper number that we have, comma, and how many numbers we want it to spit out. So right now it's like 1, comma, 20, comma. So only black calculators. 1, comma, 20, comma. Then let's just have it spit out 5 numbers for us. So hit 5, close your parenthesis, and then hit enter. So if you have a black calculator, I'll come around and help you. So you should get 5 numbers in a little set symbol. And 5. So here, it should look like rand int. I'll just write it up here. So you should have rand int, and then 1, comma, 20, comma, 5. Now, pink calculators, life's easier for you. This 1 is your lower. Where it says lower, type 1. Then go down to where it says upper, type 20. Then to go down to where it says like how many. I gotta look at one to see what it actually says. It says n, the number that you want, like how many of them, type 5. Yep. And then hit paste. Like go down to paste and then hit enter. And then hit enter again because it puts it out on your screen. This is choosing 5 numbers between 1 and 20. Now, I'm going to blow your mind because your calculator is going to make your life so much easier. Let me see this. No matter which one you have, pink one or black one, give me your eyes. This button up here that says second changes all functions to their secondary operation. Above the button that says enter, it says entry. That means its secondary function takes what you just had plugged in and does it again. Everybody hit second enter for me. Notice how it copies what you just did. Now hit enter again. You should get 5 more new numbers generated. Stick up a hand if you're having any issues with that. Second enter, enter again.
I want to do it a 3rd time.
Alright, now hold on, because you needed to know those skills before we're able to move on. So, now give me your attention back. Put the calculator on your desk. Okay? So you needed to know those skills for a moment. If we come back here to, what was our first, well, I can go back in our notes. Our first probability for game 1, probability of being prime versus not prime, 8 and 12, right? 8 and 12. Then we had 10, we had 6, we had 14. So if this, part B, look up at the TV or in your book, part B, in which of the 3 games is player X most likely to win? Talk with your partner for a moment. In which, because remember the 3 games, here's X winning up here. I'll bring it down here because some of you guys aren't looking. So these are X winning, right? Not divisible by 3, even, or prime. Talk with your partner. Which game is the best for player X? Then we're going to move on and use your calculators. I'm going to get that one on this page too so you can see. This is why you guys want your notes all collected in one place so you can compare things with each other. So, Emma, what do you think? Is the chance better going for prime, going for even, or going for not divisible by 3?
The better chance is not divisible by 3.
Why?
Because it's a bigger number.
Yeah, 14 is the biggest numerator that we have. So if player X wants to steer the game to making him win, play game 3. Play not divisible by 3 versus divisible by 3. Now, Eleanor, what if player X is feeling fair, and he wants to make the game fair.
He should do the even one.
He should do the even one because 10 out of 20 versus 10 out of 20, those are both the same probabilities. What if we want player Y to win? Okay? Or not, we can't really make player Y win, but player Y to have the better chances.
Or divisible.
That favors player X, right? This is when player X wins, then not divisible by 3. So that game 3, the rules are already determined. Player X wins here. Alan?
Not prime.
Yeah, game 1. Right?
Yeah.
Prime versus not prime. Player Y's probability in not prime was 12 out of 20. That's Y's best chance. But Y's best chance versus X's best chance, X still has a better probability if we play game 3. So now, with your calculator, we are going to run this test 10 times. You can change something when you hit second entry. So everybody, again, grab your calculator, hit second entry, but don't hit enter after it plugs it back in. So hit second entry to copy the randint 125. But we're now going to go up to the 5. So use your directional pad, go up till your black flashing box is on the 5. You can't do it, stick up a hand.
Done.
Right here. The bottom 5, the one you just pasted in. So hit second enter to copy. Now go over the 5.
Here, step up.
Change your 5 to a 10. Change your 5 to a 10, and then close your parenthesis again. Change your 5 to good. Change 5 to a 10 and close your parenthesis again. Are we good? Then hit enter. The only thing this changes is instead of giving you 5 outcomes, it gives you 10 outcomes. So, if we do this 10 times, and that the choice of how many times you have it spit out at once is totally up to you. Can anyone tell me whether you would preference getting 5 outcomes at a time or getting 10 outcomes at a time? I have a preference, and it's actually 5. That's your calculator. Ooh, no, 10 does still fit. Okay, so, well, depends on what your outcomes are. Anybody's 10 outcomes take up 2 lines, like 2 answer lines, or have to scroll left to right. If your outcomes, so can you see both brackets? These things. If you can't see both of those, that means you have results that you can't see and you have to scroll. I don't like that when my calculator makes me scroll back and forth left to right. So I would prefer to generate 5 outcomes at a time. It doesn't make a difference. But you gotta get to however many trials you need to make. If we are told we need to play the game 40 times, and I run 5 at a time, how many times I have to run that on my calculator? 8 times, right? If I generate 10 outcomes at a time, how many times will I have to run it on my calculator? Only 4. So that's the difference. So with your partner, generate 40 outcomes. However you do it, whether you do it 5 at a time or 10 at a time, and then, hold up. No, 40's, we don't have enough time to do 40. Let's just do 10. However you generate it, I'm going to clear this, I'm going to change my instructions. That 5 minutes at the beginning is goofing me up. So play the game 10 times. So what you just did, essentially that output is good. And I want you to notate according to your experimental probability. So in your notes, please write EXP probability. We'll know that's our abbreviation for experimental when we do it. According to your experiment, what was the probability of getting a prime. Essentially, how many primes? Oh, well, how many times did we do it? What's our total here? How many outputs did you just get? 10, right? So we have 10 outcomes. Your answers will be unique because your random generator is different than everybody else's. So however many primes you got over 10. Then for even, count how many evens you got. Do not run this again. We're using the same set of numbers. That set of 10. Or if you ran them 5 at a time, 2 sets of 5. But do not run it again. You're using that set of 10. So with your partner, what's the probability of prime? What's the probability of even? And what's the probability, let's just say it is divisible by 3.
Alright.
And they should all be out of 10.
So this is not prime, prime. So 1, 2, 3, 4, 5, 6, 6 out of 10.
So Nathan, in your guys' list of 10 numbers, how many of them were prime? 6 of them. So their probability would be. This is not necessarily yours. That was theirs. They got 6 results that were prime. Yours might be different. Penelope, in your list of 10 numbers, how many of them were even? Only one of them? Is that the same as what we thought would happen? No. But that doesn't make it wrong. That just means our experiment was kind of weird, kind of awkward. Results that we did not expect. Mr. Cooper, in your guys' set of 10 numbers, how many of them were divisible by 3? 5 of them? Ooh, half of them were divisible by 3. Now, yours might be different, but this is when we did it. So, often, these are going to end up different than the theoretical. Often, these are going to be different than what we thought. Now, what if we only did this 2 times? Or 3 times, or 5, or what if we did it 100, or what if we did it 1,000? So start thinking about which would be better, doing it less times, like only a couple times, or doing it more times. Now, I want you to use your calculator to help solve a problem for Janelle. Janelle's babysitting some kids, and they want all 3 prizes. Prizes 1, prize 2, and prize 3 from McBurger Place. Yeah, McBurger's Place. But they make up names, right? To protect the copyright. Now hold up, we're gonna use your calculator, right? Because we want to make your life easy. I don't want to make you work. If there are 3 prizes, we can call them prize 1, prize 2, prize 3, meaning my minimum is 1, my maximum is 3. Right? I have prizes 1, 2, or 3. We're going to go there 5 times. In your calculator, hit second entry to copy that rand int again. But now we're going to change what's in the parentheses. If we only have 3 different prizes, anyone know how I should set up my parentheses? Patrick?
1, comma, 3.
What comes after?
5.
We're going to take 5 trips to McBurger's. So you should make your calculator say rand int, what we've been using the whole time, prize 1 up to prize 3, and we take 5 trips, and then hit enter. Did you, there's no right or wrong answer here, did you get all 3 prizes? Did you get 1 and 2 and 3, or did you get copies and miss out on one of them?
We got all.
You got all of them?
All one.
All one? You literally got prize 1 every single time?
Yes.
So they got 5 of prize 1. What'd you get?
We got 3 and then the rest.
So you got like all 3 and then 1.
No, all.
Oh, you got 3, like only 3s and 1s?
We got 1, 3 and the rest.
Oh, so you still missed prize 2? What'd you guys get?
4 1s and 1 3.
4 1s and a 3. Did anybody get all 3? What'd you guys get? 2 1s, 2 3s, and a 2. Kate?
2 1s, 2 2s.
Interesting. So we're gonna pick this up tomorrow and talk about how randomly generated numbers work. Hey, I still have a couple minutes with you guys, so here's what I need. One person from your group, bring back up the calculator, set them right up here, please. They just sit right up on this binder as we trade them, yeah, but not very often. It's better than replacing batteries. Batteries are expensive. The black ones take 4 AAA batteries. So, all right, thank you guys. Please try level 1 and 3842. Hey, there's a graphing question on 42. I would suggest getting a chunk of graph paper and just keeping it in your math journal. Thank you, thank you.